Senior Product Marketing Manager at LONGi Solar, Jason Yan. Jason will share today the evolution of PV cell and module technology. Welcome back to TaiyangNews, Jason. This is not your first time with us.
Hello, everyone. Thanks for a nice introduction. So this is Jason Yan from LONGi. I'm very pleased to give a speech here. So as you mentioned, today my topic is the evolution of PV cell and module technology. I will share my screen now. Hold on for a second. It seems I cannot. How about now?
Yeah, good.
Okay, so here we go. Basically, my presentation will include 3 parts. So first part, I will introduce the evolution of PV cell technology. And second part, I will introduce the evolution of PV module technology. And lastly, I will introduce our new product, which is HYMO 6. So firstly, I will introduce different kinds of PV cell. As you may know, so for the solar cell, basically we have 2 kinds of cells. One is the silicon-based solar cell, and another segment is the thin film solar cell. So in terms of the silicon-based solar cell, we have aluminum BSF cell and PERC, TOPCon, HGT, and for the IBC cell, actually it can adopt all the kinds of passivation technology, as I mentioned. And as for the thin film solar cell, we have the gallium arsenide solar cell and also the cadmium telluride solar cell and the CIGS solar cell. So we can see for now, the mainstream passivation technology is still the P-type PERC, and potential next generation passive technology will include the P-TOPCon and P-polar BG, P-polar FG, and M-polar BG and TOPCon HGT. So whether the subject is PON is not important, as long as they can improve the passivation performance and finally improve the cell efficiency is important. So in terms of PERC cell, we can see in recent years, basically from the 2016 to now, the cell efficiency increased from 20.8% to 23.8%, which is now very close to the 24%. And we believe together with the increase of the motor size and the cost reduction caused by the increase in motor size, so PERC motors have strong product competitiveness. Also, in the same time, other cell technology and equipment are also making continuous progress as PERC cell efficiency goes to the bottleneck. Other high efficiency cells are promising, but of course, it needs to overcome several challenges. Too fast. And also for the PERC cell, we can see it has been mass produced since 2015 and is still the most cost-effective technology now. So we can see in this figure from this year to the next few years, the PERC cell capacity will be over 500 gigawatts, which is very big. So the P-type PERC cell will be still being dominating the market in the next 2 to 3 years because of a bigger advantage of the capacity, and of course because it's most cost effective. And another cell is the TOPCon cell. as many experts has introduced, I will go quickly. So TOPCon was invented actually by Fraunhofer in 2013, and the laboratory efficiency has improved rapidly since then. So basically, the commercial mass produced and TOPCon cell replaced the full diffusion layer of the Emperor cell with the TOPCon layer. And now the amount of silver, because it's higher than that of PERC cell, and thus the cost is relatively higher than PERC. And now for this year, I mean, the main technical progress is cost reduction. So it includes the rapid thinning of silicon wafer. Some companies may adopt the silicon wafer, the thickness close to, I think, 135, 130, something like that. And also the reduction of silver consumption. And for the heat rejection cells, as we know, the GGD cell using the amorphous silicon as the passivation layer, which is a back junction cell. It has a high requirements on the quality of the silicon wafer. Of course, because it uses a low temperature process, so it needs a large amount of the low temperature silver paste, leading to the high cell cost. And in recent years, the significant progress has been made also in the localization of equipment, but the overall cost of this heat rejection cell is still relatively high. Actually, it's higher than TOPCon. So the commercialization speed is slower than TOPCon. Recently, actually this week, LONGi has set a large-scale single junction silicon-based heat rejection cell efficiency record of 26.81% this year. So it's a remarkable record. And also other technical exploration have been made on the such as the indium-free and also P-type substrate heat rejection cells and LONGi. So lastly is the IBC cell. So both TOPCon and HJT are different passivation technology, but for IBC, actually it's a structured technology which can adopt both kinds of this TOPCon and HJT technology to maximize the front efficiency of the cell. But due to the high cost of IBC, but we believe that through the optimization of the structure and the process, the high cost of problem IBC cell is expected to reduce. So second part is the evolution of PV model technology. So in terms of the model roadmap, so we can see in the early industrial time, we adopted the coating glass and then to MBB, and then in 2017, the bifacial model emerged, and then goes to half cut plus MBB. And recently we have the single glass bifacial cell plus white EV, and also the high density model with a small gap. So actually the technology reducing the LCV will gradually wins. And in terms of the size roadmap, actually the size development is based on the reduced manufacturing cost of the larger wafer size. So after the 158.75 millimeters industry began to think more about the terminal requirement with considering each factors. And one example is that the bifacial PERC model. LONGi launched the bifacial and dual glass model based on the bifacial PERC cell in May 2017, where ahead of competition. And also we verified the bifacial gain and the reliability of bifacial model by third-party and customer pilot projects. So another example is half-cut technology. Basically, the half-cut technology can halve the operating current of the cells and reducing the internal heat loss of the model. So in this case, it will reduce the hot temperature, leaving room to moderate increase in the cell size in the future. And also the half-cut technology can improve the power generation performance when there are shadings on even and high irradiance conditions. Recently, another technology is co-extruder PLE. So the in early times, the application of the PoE is to meet the anti-PID performance requirements of the PERC bifacial mode. However, for the pure PoE, there are some, because there are long lamination time and low model manufacturing yield. So the co-extrusion PoE emerged. It has the anti-PID performance, and also it remains the convenience of a laminating process and the high manufacturing yield. And also the co-extrusion PoE has been applied on a large scale since middle 2020. The product has undergone strict reliability test. And in terms of high density motor technology, basically in the industry, we have three kinds of technology. One is in the left-hand side, we have round ribbon with the normal gap, so which is normally is about 2 millimeters or 1.8 millimeters. So it has a more black gap, but has a low efficiency. And then industry began to think to increase the efficiency. So then it has to the round-shaped ribbon with a small gap. So it increased the efficiency about 0.3, and with a small gap. So normally it's about 0.5, 0.6 millimeters. However, it will have some small cracks, and also it's difficult for process control. And LONGi then invented the integrated segment ribbon with a small gap. So it still has a higher efficiency, which is about 0.3% higher. And because the ribbon is no deformation before the surgery, so the manufacturing yield and reliability is better. So basically, considering the power, efficiency, and manufacturing yield and reliability, the smart surgery is optimal cost-effective technology. I will introduce the review of a motor size evolution. So basically, in landscape package in recent 2 years, we can see the width of the M10 model of 34 millimeters is the best choice for the industry after actual verification. The portrait type has obvious defects in terms of use and stability and the transfer models on site. And in terms of the scenario compatibility, since the M10 model has a unique suitable string length, which can match the 60 meters long fixed record. And also in terms of manufacturing, M10 silicon wafer and PERC cell yields maintain a certain advantage over G12. And for high efficiency cell, I mean, for such as TOPCon, the advantage of M10 are more obvious. So in the first half of 2022, with M10 72 cell motor size of a major company began to be standardized to 22, 78 times 1134, which is better for the whole industry. And we can see in the PV info links estimate change in the market share of wafer size. We can see in this year, the market share of the M10 will be 58% market share. And then when it goes to next few years, so the market share of M10 will definitely dominate the market, which is over 60% higher. And also the expensive shipping cost magnifies the advantage of the M10 models in package and transportation. So together with the cost saving of 0.16 about cents per watt for the cell manufacturing, so M10 models also quickly squeeze the M6 digit market share. And last part, I will introduce our new product, HIMO6. So HIMO6 adopted the innovative HPBC technology. So it's called the hybrid passivated back contact, which is innovative technology with a high efficiency and cell with the core feature of front grid free. So by optimize the internal structure process, we can achieve higher efficiency and reliability. Actually, the efficiency is higher than 25% for the HPBC cell. it will actually, we believe it will truly lead the technological revolution similar to the replacement of multi-cell by mono-PERC. And also for the HAMR 6, it's based on the M10 standard size. So we have M10 mono wafer, which is the mainstream choice for the high yield and high quality. And also we have the innovative HPBC ultra high efficiency cell with the authentic appearance and excellent performance. Also for the connecting structure, it's a full back and contact. It's high reliable and has a reasonable weight and size suitable for handling. So in terms of the technical features, the first technical feature is it's unshared absorption. So because the no ribbon on the front, it will enhance the light absorption. So basically for the HAMR 6, it can improve the light absorption by about 2.27% higher than the normal PERC model. So in this case, it will further increase cell efficiency. And also in terms of the reliability, we have the innovative welding technology. So in the left-hand side figure, we can see the normal welding technology like traditional Z-shaped welding. The cell stress is about 15 megapascal. And in the right-hand side, we have the HAMR 6 adapted the back contact one-line welding structure. And the cell edging stress is about 26 megapascal, which means it will be more reliable and have the less micro crack. So the HAMR 6 is also demonstrated the new levels of model efficiency, and it has a significant efficiency improvement when compared to PERC and TOPCon technology. We can see for the PERC model, normally the model efficiency about 21.5%, and for the TOPCon it's about 22%. But however, for our HAMR 6, the model efficiency is close to 22.5%. So that means in the same installation condition in the DG market, compared with the PERC model, the installation capacity is increased about 6%, and compared with TOPCon model, the installed capacity is increased about 3%. And also we, for the HAMR 6, we go through a lot of restrict reliability tests. So LONGi's model have extremely low power degradation after various stringent reliability tests, no matter in the TC600 and DH2000, DH1000 and the mechanical loading or UV or PID, the degradation is less than 2%. So lastly, conclusion, PERC has huge existing capacity and will be the most cost-effective route in the next 3 years. And then by reviewing the model technology evolution, we can see the technology reducing the LCOE will gradually range the market. So M10 model is the optimal size for the utility scale power plant after considering each factors. And the future technology, we believe, should be focused on the efficiency improvement. No betting on the single technology. All promising technology are to be thoroughly evaluated for performance potential and cost trade-off. LONGi's nucleotide will be, of course, be mass-produced and be recognized by our customer very soon because of its cutting-edge technology and high value for our customer. That's all. Thank you.
Thank you, Jason. That was a very nice presentation. Just one question. So can you please explain some technical details about this world record cell? Is it N-type or P-type? And someone in the chat said that it is not a back contact, but a FRC structure. So can you please shine some more light on that?
You mean the technical details of HPBC or HAMR 6, right? So as I mentioned, so HPBC is LONGi's innovative cell technology. The main feature is that there is no grid on the front. and also it's in the, I think in the contact, in terms of contact, it's back contact with one line contact, so it will increase model reliability and also the efficiency. And also, and as we, I think as I mentioned, well, in the cell introduction, no matter what is P-type or N-type, what we care about is always the first principle, which is increase power generation efficiency and reduce the LCOE. So I think that's the answer. Yeah.
Okay, thank you, Jason. I request you to please stay on and please answer some questions. There are lots of them for LONGi, so if you could please answer those in the chat room, it would be great.
Okay.
Yeah.